In this video, I'm going to talk a little bit more detail about the OSI and TCP IP models and the different layers. First of all, just a reminder, remember, network protocols are usually part of a suite of protocols. In this example, we're going to be looking at in this presentation, we're going to be looking at two suites, the OSI protocol suite and the TCP IP protocol suite. And you can see that the TCP IP protocol suite actually maps to both the TCP IP model and the OSI model. So another thing to remember is network transmissions, digital communications typically require multiple protocols, as we can see here. With this data being sent using HTTP, TCP, IP, Ethernet, etc. Each one of these protocols has a specific purpose in transmitting the message, and quite often, but not always, they are from they're from different layers of whether we're using the OSI model or TCP IP model. This is known as a protocol stack. And what you may notice also is here we're looking at the Ethernet header. We have Ethernet down here is the lower layer. Then the next layer is IP, which is the next layer above it. Then TCP above that, HTTP above that. This is why we call it a protocol stack. So why do we have these network models, these layered models? Well, first of all, it helps us understand the role of the protocol, what its intention is, and the relationship to other protocols. Also helps us when making changes or developing protocols, knowing exactly what is the specific function that this protocol should be addressing, whether it's a network layer, transport layer, or whatever. And it also provides a common layer or common language for us to talk about a protocol. So it's very common, especially in the OSI model here, we have them numbered, usually 1 physical layer, 2 data link, 3 network, etc. That it's very common that network engineers talk about a layer 2 protocol or a layer 3 protocol or layer 3 address compared to a layer 2 address. So we use this in referencing what kind of information we're discussing. So let me just talk a little bit about each one of these layers. Now, first of all, there's a big note down here. These layers and these protocols and the relationship between them are all going to become more evident to you as we learn about each of these layers and its protocols in different videos. So don't get all caught up right now on, well, what do these exactly mean and how do they actually work and what is the relationship? We'll get there. So the application layer. This is the layer that interacts with the network application software. And we can see that both the OSI model and the TCP IP model both have an application layer. The OSI model actually divides what the TCP IP model uses as it calls the application layer into 2 more layers, the presentation layer and the session layer. And you can see I have these in italics because we don't normally refer to these 2 layers like we do the application, transport, and the other ones. But the presentation layer transforms data into a recognizable format for the application layer. And the session layer controls the dialogues, connections between computers or devices. But like I said, we're not usually going to be discussing the presentation or the session layer. Usually it's going to be the application layer and then one of these other layers, like the transport layer. Oh, by the way, before I move forward here, the application layer, these protocols include things like HTTP, HTTPS, DNS, DHCP for IPv4 and IPv6, FTP, and many other networking applications. The transport layer is responsible for any reliability, flow control, and error control. And we'll take a look at this in more detail in later videos. But TCP is all about reliability, making sure everything got there reliably, nothing missing, anything out of order gets reordered. Now, UDP is a protocol that doesn't guarantee reliability, doesn't care about order, and we'll discuss these in more detail later. The network layer in the OSI model, or the internet layer in the TCP/IP model, is responsible for messages being sent from the original sender to the final destination. Think of this as the envelope when you mail a letter. We put the who it's originally from and where it's going to on the envelope, who the original sender is and where the final destination. That's what IP is all about. We'll also look at other network layer protocols like ICMP and ICMP v6. The data link layer is responsible for NIC card to NIC card communications on the same network. So we'll talk more about this when we talk about protocols like Ethernet. So this is about getting it from, let's say, your host to your local router. And again, this will all become more evident when we look at encapsulation, and we look at Ethernet, and we look at these protocols in more detail. Last but not least, we have the physical layer. This is responsible for transmitting the bits over the physical medium, whether wired or wireless. So these are the different roles of these different layered protocols. And I just also want to mention that the OSI model, we usually refer to these by numbers, or we can refer to them by numbers. So the physical layer would be layer 1, data link 2, network 3, transport 4. We usually don't talk about the session and presentation, but they're 5 and 6. And then layer 7 is the application. Okay, let me get rid of that. I hope you enjoyed this video, and we'll be talking more about encapsulation in these protocols in later videos.